start. All right, so reviewing from before the break, we're just going to say the type of reaction here, not going to predict yet. So number 1 has one reactant. What kind of reaction is that? Decomposition. Oh, y'all are so smart. And we can abbreviate decomp. All right, on the next one we have C2H4, which is a hydrocarbon, plus oxygen. So what is that? Combustion. We're burning it. COMB for combustion. And number 3, we have an element plus a compound. So we have an element plus a compound that's not a hydrocarbon. Single replacement. Guess how we're going to abbreviate that? SR. Okay. And then number 4, I have 2 elements. What do you think that is? I'm adding 2 elements together, and it's going to do what? Composition or synthesis. You can use SYN for synthesis or composition, COMP for composition. And then the last one is 2 compounds. And so what are 2 compounds going to do? Double replacement. Guess how I abbreviate that? DR. There we go. All right, we're waking up our brain cells because I know you didn't think about this over break. Yeah, me neither. I did not think about this either. I got here this morning and went, oh, what am I doing? Okay, so now we're going to actually predict. So same reactions, we know what they are now, right? We said this one was a decomp. So I'm going to say aluminum chloride, and since it's a decomposition, I know that it's going to break down into, this is an ionic compound, right? So it's going to break back down into the metal and the non-metal, okay? So it's going to break down into aluminum and chlorine. That's the only 2 things it can break down into. So how do I write aluminum when it's by itself? Al. And then how do I write chlorine by itself? Cl2, because it's one of the diatomic Brinkelhoffs. So now I need to balance that. So I got a 2 and a 3 on chlorine, so the only thing I can do is make those be what? 6. So I'm going to put a 3 here and a 2 here, and then that makes me put a 2 in front of aluminum. Okay? All right, so the next one we said was combustion, COMB, and all combustions make what?
H2O.
Yeah, CO2. Okay, so we have C2H4 plus oxygen. Going to make CO2 in water. It doesn't matter which way you do it. It's just my habit to always do CO2 in water for some reason. All right. So when we're balancing this type, remember we check what are we going to have to put in front of hydrogen, or in front of water, excuse me. 2. It's even, so we're good. If it was odd, we'd have to bump it up. Okay. What do I need to put in front of CO2? Another 2. And then that gives me how many oxygen on the product side? 6. 2 times 2 is 4, plus this 2 is 6. So I'd put a 3 right there. Next one we said was single replacement. So what I want to know is, will zinc, we look at what's by itself, will it replace the other metal in the silver? Okay, so we need to use our activity series that you have in your notes. You do get the activity series for the test. Okay, so will zinc replace silver? It will. Okay, so now we're going to make zinc nitrate and some silver. Silver is going to be out here all by itself. It got kicked to the curb. Sad little silver. Okay, but it is silver, so, you know, shiny. All right, I need to put zinc and nitrate together. What is the charge of a zinc when it's in a compound? +2. +2. And what's the charge of a nitrate? -1. So how would I put those together? There we go. So now I need to balance. So I have 2 nitrates, so I'm going to put a 2 there, and then that makes it very easy to balance silver. Cool? All right, next one, this is going to be synthesis or composition, whichever you prefer to call it. So I have aluminum and phosphide, so I'm going to put them together, and how's that going to go together? Just ALP. Because aluminum is a +3, phosphide's a -3, so it's a 1-to-1 juncture. All right. And then we said this one was a double replacement. So we have okay. When we have double replacement, but remember we do outside, inside, right? Which do you want to do first, outside or inside? Outside first. Okay. So I'm going to, everything's a +1 or a -1. So these are our favorite because it's easy to put them together, right? We don't have to change anything, give them subscripts or anything. So I'm going to do NaNO3 plus AgCl. For our double replacements, remember we have to use our solubility rules and see what's aqueous, what's solid. If everything's aqueous, it's a no reaction. If something forms an insoluble solid, then it happens. So let's look at the first one. We have sodium nitrate. What do we know about sodium? It's a group 1 metal, which is always aqueous, no exceptions. As is nitrate. Nitrate, always aqueous, no exceptions. So that's for sure aqueous. So we do the little AQ because it stays soluble, it stays dissolved. Now let's check out the silver chloride. What does your solubility rule say about chlorides? They're always soluble unless they're with silver, mercury, or lead. So that is going to be an insoluble solid. So we're going to put a little S behind it. So that reaction actually will happen. Okay? An insoluble solid. It's actually like a white solid. When you put it, when you mix those together, you get like a white milky looking substance. But then when you let it settle, the white solid goes to the bottom. Okay? All right. A couple of more to predict, and then I'll let you go on about your merry way. Here we go. All right, so this one is sodium metal is placed in water. So how do I write sodium metal when it's all by itself? Na plus water. I'm going to write it as HOH. Why am I going to write it as HOH? To show how it breaks apart. It's still H2O, but if you think about the structure of water, it literally is HOH. So this is a metal in a compound, so or element in a compound. So what kind of reaction is this? Single replacement. Okay. So we're going to look at our activity series and see, will sodium replace hydrogen? We know that hydrogen is not a metal, but it reacts with them. So will sodium replace hydrogen? Yes. So it's going to kick out hydrogen, and when hydrogen gets out there all by itself, H2. So technically it's not all by itself. It has a buddy, H2. Okay. And then I need to put sodium and I need to put hydroxide together. So how do I do that? NaOH. Okay, now I need to balance. How do I balance that? 2 in front of NaOH, which then makes me put a 2 in front of sodium. And am I done, or do I need to keep going? I'm not done.
1 in front of water.
2 in front of water. Now I have 2 oxygen, 4 hydrogen, and 2 sodium on both sides. So we're good. Okay? Next one is methane is burned in the presence of oxygen. CH4 plus O2. I have a hydrocarbon plus oxygen, so what kind of reaction is this? Combustion. And all combustion make CO2 and H2O. All right, so let's balance this one. What do I need to put in front of water? A 2. It's even. We're good. We don't have to bump it up. And I don't need to put anything in front of CO2 because I already have 1 carbon on each side. So how many total oxygen do I have on the product side? 4. I have 2 and 2 here. 4, which means I need a 2 there. I didn't leave myself very much room. Sorry about that. All right. Last one is potassium bromide, Kbr, plus chlorine gas. How do I write chlorine gas? Cl2. I've got an element and a compound. So what kind is this? Another single replacement. This time, though, I've got a non-metal. So I want to see, will the non-metal replace the other non-metal? So I want to know, will chlorine replace bromine? Yes, it will. Thank you. So that's going to give me KCl plus bromine all by its lonesome. So the way to balance that is easy, just a 2 and a 2. Okay? Is it ringing some bells? Waking your brain back up from Thanksgiving break? All right. Your packet that I gave you today, if you look in the margin, you're supposed to say what kind it is, and then you are going to write and predict. Okay? You do not have to write the words. Like once it says like calcium plus nitrogen yields whatever, you don't have to say the words of what it yields. Just do the formulas. Okay?